statements. Is if you're running a high criticality or high risk system, this is something you should consider doing. So there's some statements in there where it says, you know, if then this. Security implications of not following these practices. All of these practices have valid vulnerabilities or valid attack space associated with them. So if you're not going to do one of these things, one of the things you could do with the checklist if you implement it as a checklist is you can go back, and when they go through the checklist, you might decide this particular recommendation in checklist is, for instance, it might be covered by something else you did. Maybe you put a mitigation in that actually covers 5 or 10 different things, right? So you may reference the same checklist or other checklist items, say see checklist item, whatever, right? The other thing is the business may decide to operate with a risk. So in some cases, operating a system in a risky way is the right answer. Right? And as security people, I know that makes our hair stand on end, but from a business perspective, we need to understand the business context that they're going to operate in. So if I'm going to deploy an application, and if I deploy it in its riskiest configuration, and I can make $1 gazillion, or I can lock it down and make it less convenient for my users and make $100,000, you know, sometimes it's worth doing the riskier run for the purpose of the business, because the businesses are in business to make money, right? If they weren't in business to make money, they'd be a nonprofit organization like OWASP. So, you know, keep in mind that a business may choose to operate at the risk. So our job as security people or development people is to help them understand what the real risk is so that they make an informed decision. We don't have to agree with the decision, we just want them to make it informed. All right. So, developing guidance documents. So these are some of the uses for the Secure Coding Practices Guide. One of the things you can do with it is if you take a look at your security documentation framework that supports secure software development, you have, typically your company's going to have some security policies that tend to be high-level IT security policies. They're not necessarily going to get into secure software development. They're basically going to say, we have some assets, they should be protected, don't do bad things, with slightly more detail. Right? Those are typically your high-level policies. Then you get into things like your application security procedures, which are the like the secure coding practices, are technology agnostic, where they say when building software, you must validate user input or encode or sanitize user input. You must prevent common attacks like cross-site scripting, SQL injection, right? So they don't tell you how to do it. They tell you that there are requirements that must be met. That's where you would have a document that actually gets created for development organizations that guides them on the requirements that they have to implement when coding. And then finally, you get into things like application security coding standards, which say, here is how you do it, right? So you're developing in Java, we have requirement, and if you link these documents, it's the best. I mean, at least the second two. If you link the security procedures with security standards, that's the best way to go, because you've said, developer, you have requirement X, and go over to this document, here's how you meet requirement X in your language, right? Because everyone wants to be told you have a job to do, and here's all the tools to do it successfully, as opposed to you have a job to do, have a nice day, right? So your development teams want the tools to do the job. I mean, most of the time, if you can make it simple for them to do what you need them to do, they'll do it. And the less they have to learn about being a security professional, and the more they can focus on what they were hired to do, which is develop, the better off you are. All right, next thing. So this is kind of an abbreviated secure development lifecycle. This does not capture the entire scope of the secure development lifecycle. It captures a subcomponent of it. So just keep in mind, I'm not promoting this as a full secure development lifecycle. I'm promoting this as some components. And I'm going to talk about one idea in here which I think is somewhat unique and that I'd like to see promoted more broadly within the industry. So again, we're getting back to the what to do, right? So this is where the secure coding practices come in handy. Tell your developers how to build secure software to start with. Tell them what they need to do so that they don't have to get beat up at the end when their software is insecure, or your companies don't end up compromised because somebody found a vulnerability and walked in the door and walked out with all your social security numbers, bank accounts, or whatever. Right? The next step is tell them how to do it, right? This is where I was talking about secure coding standards. Have application development practices that are language specific, have standardized libraries, managed code, and standard guidance for things that you can't put into standardized managed code solutions, right? It says how to do this thing. Some of the times you may need to do that because you may have If you have a large environment, you're a large corporation, you may decide to put standardized libraries in place for, say, your top 3 or 4 languages, but maybe you also have other languages like these obscure ones you know people are developing in, you know you have projects in, but in the beginning you have to do the 80-20 rule, right? So for those people, you may not build libraries, you can only have so many resources at one time, but you still should have guidance available for them that says, regardless of language, this is kind of what we're trying to do, right? Now the next thing, as you go through this is some new concept that I don't see a lot in software development life cycles right now, and that's where before you do the test, after you've said, here's what you do, here's how you do it, and then typically what happens is you jump into verification that you did it. What I'm trying to propose is that there's a step before that, and that's where somebody sits down with the development team and says, how did you do it? Right? Because there's more than one way to boil an egg, or you know, there's other terms. I was trying to say skin a cat, but that's probably not a good term to use. But there's more than one way to do things, right? So if you simply skip that what you did conversation, what happens is you told them to do something, you told them how to do it, but you didn't actually verify what they did. So then when you go to do the verification and you test it, if your test comes back okay, you just assumed, well, they must have followed the enterprise solution, or they must have used our standard coding library because they came out okay. But you don't know what they did, right? And the problem with that is twofold. One, maybe they did something bad and your security and your test at the end just didn't happen to pick up that it was bad. 2, you can also head off a test that's unnecessary. For instance, if you gave them this coding library, said use the SAPI to make sure you sanitize your input data and your output data so that you don't have things like SQL injection and cross-site scripting problems, right? And they said, I read up on cross-site scripting, I'm going to just filter the script tag, right? So you can stop them right there and say, wrong answer, go back and do it again. The other thing you can do, and this is where I think actually the greater value is when you ask them, how did you solve the problem, maybe they actually came up with something better, right? Maybe they came up with something that's somewhat unique, because the enterprise solution that you've advocated, while it's, again, probably an 80-20 rule solution, so 80% of the time it'll solve the user's problem. That other 20%, they're going to have to figure out some way to either wedge that in to make it work as a shim, or they're going to have to extend it, or they're going to have to roll their own. In some of those cases, their roll their own or their extensions or whatever they did may actually become a new best practice for your company if they improved it in a meaningful and useful way. If you don't ask them, you won't know that, and you will go on and you'll have one guy or one group that's produced this gem of a solution that you don't know about, because all you knew was that when you did your pen test at the end, it worked and everything was fine, right? That they passed. So I'm advocating that there be a conversation at the end that says, how did you solve the problem? And then you go in and you do your validation stage where you actually test the solution to make sure it really did work. Right. So some of you have probably been involved in somewhere in this life cycle, which is the I'm going to outsource software development to somebody. And you typically have a business person or an organization that says, I need cool software that does amazing things and whiz bang, and I want it to sparkle, and I want every user that sees it to immediately fall in love with it, and you know, it'll be the next big thing, next Google, next iPhone, whatever, right? So they come to, they put out their RFP, and there's a salesperson waiting for that RFP that says, I don't even care what your RFP says, I'm sure my company can do that better than anybody, cheap, and it'll be great. You'll be so happy you can hardly stand it, right? There's a sales guy waiting for that to deliver that message. And there's a coder or group of coders behind the sales guy going, oh, I hate that guy, right? So one of the things as a purchaser of software that we are in many cases dropping the ball on is getting our security requirements not only into the contract, but into the RFP before the contract, right? If you're going to bid a project and you're going to want someone to develop software for you, it helps if you tell them up front that you have all these security requirements they're going to have to meet. Because if you don't tell them up front and you still have those security requirements, what happens is you don't tell them you have security requirements, the contract doesn't reflect you have security requirements, so you come back later and say, hey, you didn't meet our security requirements. And they're like, well, it wasn't in the contract. We'd be happy to meet them for you for a price, right? Where if you get them in the RFP early and you say, we've communicated our requirements, and then you get them in the contract and they don't include them, now they're doing it for free if they drop the ball. You don't get it in the RFP and in the contract, and you ask for them, now you're paying them to do it, right? So I'm just saying, get it in the RFP so they know it's coming, include it in the contract, and also include how you're going to measure them against it, right? Because you know, trust but verify. Not that I think subcontractors are going to fib, lie, or exaggerate, because I know that doesn't happen. All right. So, summary. The guide is designed to be simple, short, easy to use, easy to digest, easy to hand off to a development team to give them a kickstart, right? It's not solving world hunger in the application security world. It's giving them a starting place to really start understanding what it is they're expected to do to make software more secure. And it doesn't specify what must be done versus what should be done, so that's an important concept too. One of the things that we're discussing, myself and some of the other project leaders who've helped review this project, is prioritizing the recommendations, because right now the recommendations are not prioritized. And part of my argument to that as a security tester is a lot of times it's not the occurrence of a single vulnerability that allows me to kibosh an application in a meaningful way. It's a combination of the vulnerabilities. And so while you might say this one is less important than this one, and that would be true if you're just comparing apples to apples and isolated and those are the only problems on the system, it becomes much less clear when you're looking at an application in a real world that has some combination of vulnerabilities, what that particular combination gives you or doesn't give you from an overall vulnerability standpoint. So we're still discussing that. I just want you guys to know that at some point in the future we may look at providing some priority around which things are more important than others. But again, my concern for that, from a tester's point of view, from a guy whose job it is to rip an application apart, it's very hard to tell how that soup of vulnerabilities is going to create something that's going to allow me to get in, right, or to do something bad. And sometimes it's a combination of somewhat mediocre problems that allow me to get in a really bad way. And so I am not sure how we're going to handle that going forward. So here are some of the OWASP projects that I link to in the document and talk about a little bit, and that I think help build a application security framework of OWASP projects, where the Secure Coding Practices Guide helps provide that upfront stuff of what should you do. You have a secure development project, the class project, which kind of gives you the framework. You have the Secure Development Guide, which tells you how to do it. You have the ES-API, which gives you managed code to help you do it. And you have the SVS project, which helps you verify that you did it. Right? So a lot of these projects still need to be pulled together in a more cohesive way so that you can implement them as a standard framework and just grab the pieces from OWASP and say, plunk it down and have it all work together. I think there's, not just for my project, but for other projects, there's some room for us to eventually grow into a space where you can come and grab all that as a package, or you can pick and select the pieces that you're missing out of your own lifecycle development and implement those and just say, I'm going to plug those in, and you know exactly where the handoff points are and what it is that they do.